Hi, thanks for joining us for Successful Air and Vapor Data Collection Best Practices. My name is Laurie Chilcote. Craig Cox will be joining me periodically. We want to share the most important things you should think about before you even go out into the field. We're going to do a live demonstration of an installation, a shut-in leak test, a helium leak test, as well as some specific active soil gas sampling tools. But first, you really need to think about what you're trying to accomplish. So let's start there. So before you even go out to the field, you need to think about the goal you're trying to achieve. So you can analyze which tool is going to get you the data that you need to get you the answers that you require, saving yourself time and money. With that.
Hello, I'd like to now show you how to install a vapor pen. And we're going to try and do a couple of things here this morning. One is we're going to install this is a flex vapor pen. It's got a little, the barb fitting can come off. This is the silicone sleeve that will form your seal. You'll see you set it not quite to the top, just enough so that you're at about the last barb. Now this may change for each different concrete setting that you're in. Some concretes seem to grip a little bit more than others. So once you put in a few, then you'll know how yours is going to react. We've already drilled a 5/8 inch hole through the slab, and we've cleaned it with the shop vac. The installation extraction handle you'll get with the kit, or you can buy separately, has a hole in one end that fits over the barb so that you can so you don't damage the barb fitting, and it allows you to pound it in. So I'll do that now. Let me put my gloves on.
Will you be showing us a shut-in leak test as well?
Yes, and part of this demonstration will show you how to leak test with a water dam, how to leak test with a water dam and a pressure test, which is probably what you'd like to do in all cases. So you first start the vapor pen in the hole, then you place the installation extraction tool on top, and you simply pound it in like a nail. And that's all you need to do. So the seal is immediate. And it just goes in. You see a little bit of a bulge around the outside. That's normal. If you have too much of that, you might want to remove it, start the sleeve a little lower, and then pound it in again. So the next thing you would do, you would purge the point. After you've let it set for a while, you purge the point to make sure you're getting soil gas, and then you can connect up your sampling train. So this would go back to a Sumacan, and you'd be ready to sample. Now what I want to show you right now is how to leak test this with a water dam.
And you made that yourself, correct?
Yeah, this is some homemade Play-Doh. It's important that you keep as few that you introduce as few VOCs to the site as possible. So we're using a homemade Play-Doh that is made out of baking soda and cornstarch and water, and we have that recipe on our website if you want to try and use that. So you basically make a snake around the bottom of this coupling that comes with our kits. Okay. Then you place that over your sample train, snug it down, and then fill that void with water. And the idea being that if the water stays above the connections, then you don't have a leak. So now you can start sampling. Now the next one I want to show you is a flush mount setting. So here's a vapor pen that's been installed previously and has a secure cover on it. You have this special spanner tool that you can engage the lid with and unscrew the secure cover. And the secure cover has threads on it that allow it to attach right to the vapor pen. So there's no other kind of attachments you need. You take out the little cap that goes on a little vinyl cap that's on there. It's actually silicone. And then we're going to show you how to pressure test before you sample. So what we have here is a hand pump that goes through a valve. Then we have another pressure gauge in the middle. Then that runs up to a valve at the top and a T-fitting, which goes into your Suma can. Now this Suma can, you want to make sure all of these connections are tight. And that's what you're testing, is how tight is this connections. Finally, this part of the T-fitting runs over to a valve at this end that's closed. So you want to close off everything back to this hand pump so you can pump up the pressure. So you pump the pressure up, and you can see on this valve, or on this gauge, we're getting some pressure. And then we'll let that set. And you can see it's slowly dropping a little bit, and that's because these hand pumps are notorious for leaking. So that's why we have this other valve here. So you can turn this valve and shut off the hand pump, and you'll see now that the pressure is steady. So that means that none of this part of the system is leaking. On these alpha Suma cans, they also have a gauge here that you can turn on, and you can monitor the pressure there. It just doesn't show up very well on the video. So once you have it figured out that you're set and you're tight, turn this valve to isolate this portion, because you don't want that to be in the sampling. Connect this to the vapor pin. Check your valves again. Then you can open this valve. Now you have a connection between this portion of the, where your subslab is, all the way back through here, and this valve is now, when you're ready to sample, you open that valve.
And you have a built-in water dam.
Yeah, and so now you have a built-in water dam with the flush mount. So if you want to test that, you just fill that with water. And again, you watch that. Just a couple bugs came out. Now you watch that and make sure there isn't any, water leaking through around the vapor pen. So the idea being that water won't, the indoor air won't go beyond the water. At that point, turn on your valve and you're ready to test.
Helium shroud leak testing, discussion and demonstration. There are two main types of helium shroud leak testing. The first method involves only leak testing the sample point, while the second method leak tests the entire sample train at the same time. First, a quick word about helium. Generally, the two types of helium that are available for use are lab-grade helium and so-called balloon helium. Lab-grade helium is extremely pure, ensuring that should a leak occur, the sample will not be compromised. However, it can be expensive and difficult to obtain. Balloon-quality helium is often found at stores for consumer use and may contain other volatile organic compounds. If a leak occurs, these VOCs can contaminate the sample or affect reporting limits. While it is easier to obtain, it can jeopardize sample integrity. Quantitative helium leak testing of the sample point. This leak testing method allows for leaks to be corrected prior to sample collection, ensuring sample quality and helping avoid costly resampling. Less cumbersome than the fully enclosed testing we will demonstrate later, this method is often combined with a shut-in test of the sample train. Firstly, the sample point, in this case a vapor pin, is covered by the shroud. This shroud has three ports, one for measuring helium levels in the shroud, a second for supplying helium to the shroud, and a third for purging the sample point. Connect the purge tubing to the sample point securely. Connect the helium detector to the shroud measurement port and fill the shroud with helium until an adequate concentration is reached. This concentration is often dependent on guidance and/or laboratory reporting limits. Once an adequate helium concentration has been measured in the shroud, connect the helium detector to the purge port and monitor it. If no helium is detected, no leak is indicated. If helium is detected, check connections and the sample point. Although very unlikely to leak, the vapor pin's design allows for easy reinstallation. Following the helium leak test of the sample point, the shroud can be removed and the tubing disconnected. The point is now ready for sampling. Quantitative helium leak testing of the entire sample train. This method ensures very high data quality by fully enclosing the sample point and sample train. Due to this method's complexity, however, it can be difficult to collect multiple samples and may increase costs. This shroud is slightly different than the previous shroud. It features the same port configuration, but also a three-way valve with connections to the purge port, sample point, and the sample itself. The sample manifold and configuration used in this demonstration may vary from others that are available, so be sure to check with your equipment provider about the proper usage of the shroud. First, connect the sample tubing to the sample point. Next, connect the sample to its respective tubing. Then, ensure that the shroud is well seated on the ground surface to reduce any helium loss. Connect the helium supply to the shroud and begin adding helium. Next, connect the helium detector to the shroud monitoring port and measure the concentration of helium in the shroud until the target has been met. Alternatively, a standalone helium monitor can be placed fully inside the shroud to measure the concentration instead of using a port. Next, we will begin the process of purging the sample point. Adjust the valve accordingly and connect the helium detector to the purge port. Purge a large enough volume of soil gas to meet your data quality objectives while also monitoring the helium concentration as before. Once the sample train has been demonstrated to be free of leaks, you can begin sampling. Helium shroud leak testing is a tried and true method for leak testing soil gas sampling points. Some advantages include the ability to identify leaks in real time prior to collecting a sample. Another advantage is the inert characteristics of helium gas, meaning that if a leak does occur, the sample isn't compromised. However, helium leak testing also has a few disadvantages, including increased costs and logistics. It should also be noted that helium leak detectors can provide false positives in the presence of methane, which can undermine their use at petroleum or chlorinated VOC vapor intrusion sites, where methane may be present in the subsurface. Please note, this video demonstration is meant only to illustrate the helium shroud leak testing process. Always consult all relevant guidance and work with environmental agencies to select and develop quality control objectives. Leak testing requirements can vary drastically between agencies and locations.
Now, one of the things we also wanted to show you is how to extract a vapor pen. And so I just have to get rid of the water with a syringe. And you might want to carry a syringe or a turkey baster with you. Okay, here's the syringe. So we'll suck out that water. Now, one of the things that we've noticed about this homemade Play-Doh is it does kind of turn a little bit sloppy on the inside. So once you get that done, you'll pull that out and you'll see it's kind of a little bit of a mess. So you pull that out, got some paper towels to clean that up. All right. Now, to remove the vapor pens as easily as taking out a wine cork, first pull off your sample train, and then you thread the installation extraction handle down onto the vapor pen. There you go. And you'll feel it engage. At that point, you just keep turning, and the pin eventually works itself up into the handle and comes out. Don't try and just pull those out because you will hurt your back there and they're really tight.
And you can remove the sleeve, clean the pin, put a new sleeve on, and you're ready to go again. Just make sure you need to put a sleeve on each time to make sure you get that seal on initial installation.
Thank you.